This conference will now be recorded.
Right. So yesterday we have seen how do we design the schema basically. Uh, what exactly, like we have done was just you wanted to design your schema so that it will accept certain formats of data and it rejects certain forms of data. So you ultimately define something on the system what you wanted and what you don't want it. Well, because Mongo by nature it does not reject any data, any format. So, but you wanted to minimize the data and with a valid data. That to invalid data it asks to reject. That's where the schema design will come into picture. You are defining a structure. Within that structure, some fields are mandatorily to be populated. Then only the Mongo will accept the data, so that you will have the all of data is valid data. What your design, what you have inside the collection. That way you can control the data if at all you wanted to. Why? Because of Mongo is very rigorous in terms of data pickup, basically. And data modeling concept. This is almost like discussed anyway. If we see in Mongo, we try to keep the data in a single document. We don't spread the data across different collections and join it. There is no join concept in Mongo, first of all. We have to keep that in mind. When we are loading information about one entity or one person or whatever it is, the complete information should be there in a single document. That is expected in Mongo. If you distribute the data to different collections, a single information, you cannot join them. So it's something, whatever the information, just example, quickly do it and then I'll close it off. Maybe 5, 6 minutes, 10 minutes we'll spend on this quickly. Data modeling. So you design your, like a document like that, you have to, no need to go to, like a different collections and load the data about each person. If example, you wanted to load the data which is already there and you wanted to add some fields, you can add it. Like we have set option, right? It will add automatically the new fields and then load the data automatically. When the structure get changed, that is what it does automatically. So example, we are loading some student information, assume a case, inserting some data. Students information, so this is a minimum syntax we will have it, right? This is a minimum syntax we'll have it. Parenthesis. Within the parenthesis, we'll have a minimum of curly brackets. This is where you enter the data. Okay. So here you define the data. Anything that you want to define, you will define in this one. So example, I'll define just for the sake of discussion quickly. S name. S name I'm keeping as my case. Santosh. Come on. And last name of that person. Okay. I'm just keeping S just for the sake of discussion. And we discussed this anyway. So one student can enroll into multiple courses. When that is the case, you just keep the data in the local. And then you might have the addresses, primary address and secondary address also. It is possible, right? So if you wanted to go with MBD documents, again, it will be like this. Inside the document, another document. You mention the information here, like what street you belong to, what is the building name, what is the flat name, all that. So I'm just keeping some name it here. The motto of here is, like keep the data locality. Don't try to distribute the data to across the collection, so you don't have a choice to club it or join it, kind of. Okay. So city something. So I'm just keeping some data, guys. I'll explain with this. We have one example also. That is why I'm writing it again. We already wrote this kind of data because I'm writing it again because we have some discussion on this. Okay. and country of origin. So something like this. Now he actually, picked up a lot of courses for, like courses and all. Let's see the courses. So when like when you wanted to give the courses, like multiple courses he picked up, like I'm going with array, like maths, physics, chemistry, something like that. Okay, he has multiple phone numbers, maybe phones. I'll go with the document. So why I'm discussing all this, anything that you wanted to add about single person, it must go into single document. So here, I'll tell you that primary contact. Maybe you might be having two different phone numbers. It is possible, right? One can have two numbers. It is so absolutely possible nowadays. Secondary contact, right? That is the end of that document. Again, you have to keep comma here. And further, what else you wanted to give? His email ID. Maybe you wanted to mention his email ID also. Email ID Santosh @gmail.com, something like this. So if you whatever the information about you wanted to mention about one person or one entity, whatever it is, you keep the data locally it must be. So generally, like you keep this kind of information in a single collection, but you don't change the structure for every document in the real world basically. The structures are quite similar almost. Maybe you might be adding one or two fields extra to the existing application which is already running. Maybe, like you will see one or two fields extra, but the complete structure won't differ basically. That is where the collection will come into picture. Related data, same kind of data you keep under collection. Don't mix the different data into on a single collection. If you are picking up students data, student collection, teachers data, keep in teachers collection. Don't club it. HR data will keep in HR only. So you're not supposed to club the data for each department, keep different collection. And when you're giving the information about one person, keep that information in a single document. Don't distribute it. That something must be taken care. If not, there will be definitely a problem. So go and I'll make it as see something like this. It's whatever it is. Just I'm giving the information, guys, nothing else. And I'll keep we already talked about it actually. So media document I should have discussed here. Just I'm keeping the minimum details here, guys. Maybe enrolled into different biochemistry and all that. Contacts are some right, something like this. So now I'll go and pick up this content and load into the database. So first I need to enter Mongo. So DBs. Oh, I should. Okay, anyway, I'll type it. Skill DB. Show collections. Do we have student collection? No, we don't have. So I can insert this. If I do this, somewhere, where is the error? We need to understand. Chemistry is not defined. Oh, the codes are missing for this. It's mandatory. Okay. So you need to know how to read the error as well. Errors are very useful to understand. The error will tell you the problematic thing that you have in your code all the time. Right, paste, right, right. It is inserted means it went fine. If you db.student dot find, you'll see the data like this basically. And if you wanted to read more organized way, use the pretty option. This will read the much, it load the data much better way so that you can easily read the data. It will load as it is, as document is loaded. Something good basically to read it. All right, I'll keep this as a reference. I need this data for the next discussions anyway. So MBD documents. MBD document capture the relationship between the data by storing the related data inside a single document structure. MongoDB documents makes it possible to embed document structure in a field or array within the document. This is what it is talking about. This is a parent document. So if you see that this is a parenthesis, within this we opened again child document. This is child document. This is another child document, and this is kind of array document within the document. So it is possible you can go with a multiple nested, like documents. Nested documents means document you have one more embedded document. Within the embedded document, you can create one more embedded document. It is possible. There is no restriction, but try to keep the data locality. That is important. Keep the information about Santosh, about everything, his career, his professional, everything, whatever you wanted to keep in your system, keep under this particular document only. You cannot create in another document and join them. There is no join concept. Because of that, try to keep the data under one document itself about one person. That's how it is. Grouping documents of the same kind together in the same collection allows for data locality. Basically, you had to, that is what I was saying. Like, if we are working and you have a multiple entities to work with, like one is student, teacher, HR, and admin, different departments are there, and keep their data into separate collections and don't mix them, and try to keep the same structure. See, if one student, example, one student maybe the similar, every student this kind of things will followed. Maybe the courses may change it, right? The courses may change it, and contacts also, maybe one contact would be there, right? Email definitely will be there, and his details also mandatory, and course details are also mandatory. It seems like, if you are loading n number of students, the structures are similar but very few minor changes. Maybe he enrolled into these courses, other person will enroll into different courses, but array remains array only, and the rest of the contacts will details will maybe one contact you have it. Then if you one contact is there, this it will just say phones equal to the phone number directly. You don't need this embedded document here. So it all matters. But if you look overall, if you look at the structure will be same for all the documents within a single collection. Almost. Maybe a few things are differ, but almost the structure will be remain same. That will make the data locality and easy of grouping data basically. So in general, use embedded data models when one-to-one and one-to-many relationships between entities. In these relationships, the many are child documents always appear with or viewed in a context of one or parent document. If you see, one-to-one means you keep one information in a single document. Embedded document, one-to-many, like this is related. See, you're keeping the student information, his address information, his phone's information. It is something, more and more details are getting into involved. That's why this one to many relationship will come into Mongo here basically. In general, embedding providing it provides better performance for read operations as well as the ability to request and retrieve the related data in a single database operation. Of course, anyway there is no join, so you have to keep the data in the single document only. When if you have to read about one entity, it is mandatory. Embedded data models makes it possible to update related data in a single atomic write operation. So you wanted to update information about one single entity, like whatever you wanted to do. The data is together, as simple as it is. All right, this is like embedded document. We have just seen a big example than this. This is a big example. Like we have embedded document, two embedded documents, one array in this, all that, right? So in general, use embedded data models when you have contains relationship between the entities. See the one-to-one, this is same thing guys. Query on embedded documents. So when you query it, actually, there are two things we have: exact match and equality match. What you want it basically. exact match basically. If you so exact match means just giving the direct value. Maybe uh, if you see the bio, if I wanted to read courses who are enrolled into bio, what should I do? db dot student dot find. This is the minimum, and courses. Courses, just I'll give you the bio, that's it. So you got the record. You are giving exact value, but this is called equality condition basically. We have seen that equality condition, equality match, and exact match on the embedded document. Okay, embedded document. Embedded means this way it is. Okay, so if example I wanted to match with the wherever whoever belong to Kukatpalli example, I wanted that record. How do I read it? The Kukatpalli record? So first you have to give the parent document address, right? Then a street. Then this must go in the quotes actually. When you give this, embedded document, when you're reading it, it should go into quotes, and then mention that, like your address, your first you're mentioning this, under this you're mentioning street, and what under street, what you wanted to, you wanted to filter, like Kukatpalli. If I do this, it picked up that record. Only one record is there with this Kukatpalli. And embedded documents, we read that way, like, dot notation basically, with the dot notation. Here it is embedded document anyway. Favorites dot artist Picasso. So favorites is a parent field, and this is a child field. Under artist, whoever is playing Picasso, that is details, the artist detail, it is pulling it out like that. This is a kind of information, guys. You need to know all of this. We will see the indexing today, just quickly.
Can
Uh,
you copy that, Ravi? Those
uh-huh,
logs in the notes, yeah, like
uh-huh.
in notes. Can you copy that?
Oh, this notes, I'll give it this one. How you read it, we discussed all of this. Anyway, I'll send this one. Just a minute. Just a minute, guys.
This conference will now be recorded.
Right. So we know how to like deal with the embedded document. This is one of the main discussion you need to have it, especially we will talk about this with the indexing model as well, how we can create an index on the embedded documents and how we can retrieve the data with the best execution plans. We're going to see how we can create the indexes and all that. So first let me pick a few example and then enter into the indexing part. Indexing part, it plays very bigger role in the admin part and play very close attention, and this is very interesting topic anyway. So let's see what are the collections we have. These are the collections we have. So I'm going to enter some data just for our discussion. So do we have lab? No, we don't have lab. So insert. So S number, S name. I'll enter a lot of data. This is something need for a lot of discussions. I'll use this embedded document. I have entered that on purpose anyway. And what else I wanted? Phone number, page number, and email.
There is typo on the phone number.
Which is fine. This will pick up anyway. PH number also. Okay. So address. So next record. So this data is required for the next discussion. Indexing. So indexing is very interesting topic and important to understand. If you wanted to improve the performance, you need to know how you deal with indexing. It's any product basically, not only this, right? So IDs I'm keeping intentionally similar. Let me enter a few more records here. So why I'm entering, I'll tell you, because you need this kind of data to understand the next topic. We have three twos, oh, three, four, maybe one more card is enough, most probably. All right, so if we see db.lab.insert, sorry, read, find, this is the data we entered just now. So when the data is less and you're reading without indexes, that is okay, can be handled, and you don't see too much of impact on the system. But when there is a huge data, millions of billions of records are there in a single collection, and if you don't use the indexing model, anyway, it is like you have 1 GB or 10 GB. If you have more data, the indexing must be introduced properly based on the read patterns. You don't just create any indexing just on blindly. We need to know the read patterns. How do we know? How do we trace the load? How do we introduce the proper indexes? We have separate performance tuning model. There also I'll talk about how do we introduce the proper indexing. How do we trace a query if it is running for 5 seconds, 1 minute, 5 minutes. We can give the time. We have a profiler in Mongo also, so we will enable it. And it is so simple to find out which queries are running for longer time and how you really tune them to make it faster. We will see all of that details in detail. I'm going to talk about that. I'm expertised into that area anyway. First, if I'm reading this, if I'm reading all of these records, first what happens? Let's go on db.lab.find. I'm giving one filter here, so just try to follow. If I'm giving one, how many records it should return actually based on the data? How many
One.
records? One, that's correct. So, but how many records it is reading in the background to pull that one record? It is giving you as a one record because you given a condition, but in the background system, how many records it is reading basically? So let's
Nine.
all right. So if you see, it is going with the collection scan. Basically, first thing is, like we'll get into the execution plan more in detail. First, try to understand db.lab.find, and I'm just reading one record. I'm looking at the execution plan. The execution plan is saying that collection scan. Scan, if you use a collection scan, it is a very bad operation. Your read is not actually have good indexing model. That is the reason it is going with the collection. It is going to the collection scan. Then if you wanted to dig into more of that one, there is something called execution stats. This will give you more information about how execution actually going in the background. So you need to understand this at the end of it. So this is the execution plan of that query. This is complete execution plan. If you see, it is going with the collection scan, which is very bad. Again, if you wanted to see how many document it is examined, total 9 documents. Total it read 9 documents, but it is given how many documents as an output? One document. For giving you one document, it is reading all of its document. All of means 9 documents it read. So which is not good, right? Which is absolutely not good. So this kind of things goes happen, what happens if you have lots of data, 10 GB data, but you are reading only certain records, it load all 10 GB into the memory, it will load and then sort and then give you the data. So it's reading all of the data from disk IO. You are flooding, and you are flooding the CPU. Why? Because you're asking the CPU to process more data, and you're reading a lot of data, you're loading the IO also, and a lot of data you're pulling into memory, you're like flooding the memory also. So you're flooding all the system resources because of inefficient indexing model that you have. Example, this execution plan is clearly saying that you are going with the collection scan. The collection scan is means it is scanned everything, and once it is read into memory everything, how many has written? One. But how many it read actually? Total document examined to give this one is 9 documents it is examined to find your conditional. So if we have a proper indexing on that particular thing, it won't read all. It will read only one document only, basically. It won't read all. So I'm going to create an index. So anyway, no need to worry. I have the slides I'll talk about. So we'll see that about it. What is
Does
about
it give a cost and all those details?
cost and
Yes.
all? It won't give you. Time it will give you. The execution time it will give you. The cost wise, it is not so sophisticated like RDBMS. RDBMS, it will give you the cost means of where the weight is actually more. It's not like that. It just index model, like where like if you are going with the indexing scan or collection scan, what it is using. Index, say IX scan. IX scan means index scan. Collection scan means it is just reading everything basically. But if you wanted to, I'll talk about that. What you are referring, I'll talk about that. But it won't give you the like a cost where the weight is more. It will tell you the overall execution time, how much time it took for completion of this query basically. Wait, where that execution? This is the one. Execution time in milliseconds estimated is if you see this one, it is 0 seconds it took basically to finish this execution. Execution time in this estimated, this actual execution time of the query basically. Here we have limited data, that is why these two are matching. Sometimes the estimation and actual execution plan time may differ. It happens. Okay. So now what I'm going to do, I'm going to create an index. So there is something called default index. Let me come through the slide only, guys. Why to make you something kind of. See, indexing is actually every product, the indexing model is same. There is no difference basically. If you understand one product indexing model, other even RDBMS is also very close relationship, a little different. Mongo indexes are little different than the RDBMS. I'll pinpoint that where it is different. So, but why we need indexing basically? Indexes are required. See, indexes support the efficient execution of queries in MongoDB. Indexes will directly give you the data locations to the execution, so that the executor, the optimizer, what it does, it will contact the index. The index knows where the data physically sitting, and it knows how many records it has to read directly. It won't read unnecessary records at all. because optimizer will contact the index. Index knows all of the data records location physically where they are, address location. So it will go and pick the data from there directly. It won't read unnecessary data and sort and pick up the data what you're asking from the memory, basically. That is going to make a lot of difference in terms of execution time, basically, the indexing. So indexes support efficient execution, of course. Without indexes, MongoDB must perform the collection scan every document of a collection, which is not at all good. If it is a small, good enough, but if you have if bigger and bigger going, down the line, your collection becomes, like very big, then you don't have index. It is going to impact the performance very badly. If an appropriate index exists for a query, MongoDB use the index that can limit the number of documents it must read. So in our case, just we have seen in our case to just read one document it is written, but it read 9 documents in the background. So this is something is a load. That is what it is talking about anyway. If you have appropriate index, then it will limit the number of reading the documents. It won't read all unnecessary documents. How it is going to, we're going to see practically. Indexes provide high performance read operations for frequently used queries. Actually, indexes are only useful for the read only. No other operation will get benefit out of the index. Only read basically. So of course, you're putting the data means you definitely have to read it. You definitely have to read the data for some purpose, which is mandatory. When you read it, you need the indexes. Indexes are a special data structure that store the small portion of the collection data set in an easy traverse form. Index is also data. It's kind of metadata, where data is sitting. It's information about your data. So it's kind of metadata only. Fundamentally, indexes in MongoDB are similar to indexes in other database systems. So indexes are everywhere same. We have a lot of different types of indexes in Mongo, unlike SQL, clustered and non-clustered. That's it. Index concepts are different, but types of indexes are only two basically. We have clustered index, non-clustered index. In Mongo, you have a lot of different types of indexes. I'm going to talk about one by one. Better. So I thought like discuss something random, but let's go with the slide. Let's go with the index by index. That's where you get the more insight on this. MongoDB provides number of different index types to support specific types of data and queries. Lots of indexes. Default index, single field index, compound index, multi-key, text index, two-day class, two class I'll spend on indexes especially because so important. So whatever frequently used, basically these are the things we use very frequently. This is something we don't use it. Sparse indexes, geospatial indexes, and hashed index anyway. So where this will be used also, like I'll give you a fair idea, no need to worry. First, let's go with the single field index. Okay, this is a single field index I'm going to talk about anyway. So now, if you see here, I'm trying to read one record, and that one record does not have index. So if you wanted to see how many indexes are there in existing collection, db.student get indexes. You have to read this one, get indexes. This will tell you it has one index. It is a default index. Just we have a topic on this one. Next slide. No need to worry. So I'm going to create an index, db.student.find. This is the data. I'm going to, oh, sorry, it's not student. What was that lab, right? db.lab.find. All right, this is data. I'm going to create index in a single field. What is a multiple compound index? All that we'll see. But for now, single field. db dot collection dot. You have to give the collection. Come on, collection dot create index. Okay, and on which field you wanted to create index? I want to create index on S number, and it is 1 or minus 1. It is mandatory to give it. What is a 1 or minus 1? 1 means data is sorting, index is sorting the data in the ascending order. Minus 1 means descending order. So let me tell you that what is the index. By default, index will sort your data, which is very efficient in terms of sorting. What exactly I mean that? Let me tell you this. This is another important thing you need to understand. How index will work in the background. Example, I have the data like this. S number, How do you identify default index? Yeah, that's next topic. No need to worry. I'm single field. Next, I'll go to the default index. No need to worry. S number 1, assume a case. S number 3. Data is randomly entered like this. S number 6. Okay. S number 4. S number 2. S number 7. Okay. 2, 3, 4, 5 did not come, right? S number 5. S number 8. S number 10. S number 9. So you have the data like this. S number, we are creating the index. The data is not in the order. It is a random fashion data was loaded. When you create the index on the S number like this, S number 1, in the when you're creating the index like this, what happens basically? What it mean basically? What it means it will create the first pointer, it will go to this one. What is the next pointer? It will keep the data in the sorted order. The references of the data, it will keep by default sorted order. You don't need to sort. If the index is created, the sort is already done by the index. Sort means it is keeping. This is the first reference of the index. Okay, of the on that one. What is the next then? Next is 2 because it's in order. This is second one. Third one, where is the third one? Third one is here. And fourth one, where is the fourth one? Is here. Where is the fifth one? Fifth one is here. So it is keeping the references in the order 1, 2, 3, 4. It is keeping the order in a sequential order. Though data is jumbled or somewhere it is scattered, doesn't matter. It index what it does, it will go and keep the references in the order. If I'm reading the data using this, it will keep these references and read the data instantly. It is sorted by default by the index. You don't need to sort. Index, if you are creating the data, the sorting is already done, ascending and descending on the data. Though the field data is jumbled physically when you are reading it, it is jumbled. When you're reading it is jumbled only. How you load the data, that way you read the data. But when you create the index is keeping the references in the order. Are you guys following here? It's a very important point I'm making. Say
Yes,
something.
Ravi, yes.
So that is what, guys, index 1 means ascending order or descending order. You definitely have to give that value. Without that, it won't create. You have to tell the index. If you don't give the example, if there is no sort order, if you are trying to sort the data and if your data is exceeding 32 MB, Mongo will not sort the data. You must have the index because Mongo intentionally kept that limitation. If you are reading the data and you're sorting some data without index, if that data exceeding 32 MB, it will throw that. Insufficient, the allowed memory for the sort operation is exceeded, it will throw the error. So it's intentionally they made that. Anyway, we have that topic in the next slide. So I'm creating an index called S number on the S number field. So it is keeping the references in the order. It is created an index. See, it is created first before creation. See, number of indexes before, number of indexes after 2, which means it is exceeded. So now I wanted to know what are the indexes I have. This will tell us. Come on, why I'm reading student? I have to read lab. There are a lot of things with the index. No, I'll explain everything. This is the default index. I'll pick up in the next slide. What is the default index? How it is going to help us? But this is what our user index basically. So I created on this number. Now let's go and read cls db dot lab dot find. Let's see the execution plan, how it actually behaves. db dot, the same record I'll try to read. db dot lab dot find. Now first let's see the normal explain means it will give you the execution plan. What it said? Explain is not a function. Oh, sorry. If you see, it went with the index scan. Clearly, it is saying that it went with the index scan, which is good. If index scan it went through, then it's absolutely good. If you wanted to go in detail of it, the same thing. but you have to pass the extra parameter called execution stats. If you wanted to see the complete execution plan of the query, execution stat, it is not executing, it is giving the execution plan of that one. It's like include execution plan kind of. If you see total number of document examined, how many documents is examined? One. How many examines? How many documents it has written? One. It is reading exactly one document, and it is giving you exactly one document. So you have 1 billion records. It is reading only one document out of it and giving you one document out of it. See the saving of the resources. Index plays very bigger role how data like retrieved and how system resources are utilized in the background to give you the data what you're asking for. So previous case it was read total document examined 7 and written 1, but here 1 only. Exactly. So now let's go with a little bit more. So db.lab.find. If you see we have IDs of 2 or 4, we have 3. So now let's see, so you have to tell me how many records it will read. So example 4, if I'm giving, what it does, will it use the execution plan? Yes or no?
No.
Why?
Explain spelling.
Why it will not use the execution plan?
Yeah.
No, there is no indexes.
Hmm?
There is no indexes in serial number 4.
Why it is there on everything? See, it is not on one. The index is created on the whole field, S number field. One means not one. One means ascending or descending order. Don't confuse there. That one means not for one. It is for entire. Anyway, it is going to read 3 records because indexing has 3 records. It will use execution plan anyway.
Okay.
Right. Oh, come on, what happened? Execution stats. Sorry. What's wrong? Okay. This must go in quotes. Right. If you see, now the case is like, if you see, total document examined 3 and returned 3. Why? Because 3 records are matching the criteria. 3 records are going with the value of 4. That's what we have seen, right? db.lab. So I'll conclude with the, how we can do the complete performance tuning in Mongo. Like we have performance separate discussion in this module itself. We'll see that. So now fourth, if you see the 4, there are 3 records. It read 3 only exactly. Now, how to identify how many indexes in a collection? That is what, right? We have read that one. db.get indexes, db.lab.get indexes. This will tell you how many indexes you have on a collection, basically. You have this is one collection, this is one index, this is another index. Like when you are creating it, also it will tell you the count anyway. So now let me ask some more thing. db dot okay lab dot find. I'm going to read s name. Sorry, s name. Whoever having this name, maybe Santosh. We have multiple, right? Now what happens? What happens now? Tell me. If I do this, will it use a index?
No.
No.
No. Then what happens? How many records will read?
All.
2 records.
All, basically. All. It will examine all.
Yes.
Why? Because it does not have index. That's how it is. So you have to understand the pattern. You don't create the index blindly. I'll tell you with a lot of different ways. You get it at the end of it. Not worry. If you go it is collection scan. It examined again all the documents, but it is written 2 documents because 2 documents are giving you the It means two documents are satisfying the condition. That's why it is written two, but it read all documents. This is not at all good. Then how you make the efficient plan for this kind of reads? That is the next topic, compound indexes. So we just read about the single field index. Single field index will work on that field only. If you are including that field in the condition in the predicate, then it will use the index. If not, it won't. Predicate means the condition S number, it will use the index. If you don't use a S number, example, the same thing. Let me tell you this. If instead of this, I'll give the, again, both should match, right? So if you have multiple S number, 2, right? I'll give the another condition, S number 2. You can give this. If I give this one, what happens? Will it use the index? It's another question now.
Yes,
Yes, it will use
because
the index because
there is
index
already
column is included. Yeah, it using the index. But again, this indexing still is not efficient. Why? I'll tell you. If you see total number of documents examined, how many it is examined? 4. But how many it is given? 2. Why it is examined 4
because
when it
four
required?
serial number is student numbers are four.
Right, that is what you have to understand. So basically, we have the different data here. 4, if you see the two IDs are 4, but at the end, how many Santosh we have? 2. So it is filtered on this index, okay? But when it come to the next criteria, it is only two documents are satisfied. But I wanted only 2 to be examined, 2 has given. So that is something comes on the multi-key index, no need to worry. Compound index, not multi. So there we'll talk about it. That is why I intentionally made this data. So let's come back to slide. See guys, MongoDB provides complete support for indexes on any field in a collection of documents. Any field you can create, there is no issue. By default, all collections have an index called ID field. So you don't need to create an ID field index. By default, it will create an index called ID. When you are inserting any record, see, let me show this quickly. Let me show collections. Okay, and these many documents we have. So I'm creating a collection called db dot okay, create collection. I'm creating a new collection which is not there right now. So it is a brand new and empty collection. I'm going cloud. The collection name is cloud. It got created without the data. So show collections cloud. Did I create any index on this one? Yes or no? Did I create anything?
No,
No, but it'll have the index by default. Get indexes. That is called a default index. If I read this, there is a default index. ID field index is created by default. And then if you see this on a collection, this naming and all I'll discuss, no need to worry. But try to understand, there is a default index. The default index is there on the ID field. ID field act like a primary for us, basically, primary key. You cannot duplicate the ID field in the collection. It is fully automated. MongoDB will manage it how it has to be unique value. So if we go and read again this thing, see, this is ID field. This ID field is unique all the time, unique all the time. So why we need ID field, we talked about. It will give you the insertion order time based on the time. And if you wanted to troubleshoot what is the last date, last record is entered in the Mongo, this ID is only evident. Okay, this is the date the insertion has been happened on that one. And this is a default index is getting created on the ID field by default. Okay, you don't need to create that. Applications and users may add additional indexes to support the important queries and operations. This is for the system data. Basically, this is system data. It's not your data. It is generated by system basically, and that record is required for some reason for us. So example, if I wanted to sort the value based on the ID, it need an index. Without index, you cannot sort based on the timestamp. That is one big reason we need a default index. db.lab example. find. Okay, I'm going with the based on the ID field. ID, I'm giving. Oh, come on, sorry. Anyway, fine. I'll go this way. Everything I wanted to read. Sort. This is how you have to do it. Sort. ID. Ascending order, descending order, you have to mention. How does it go and read in the ascending order, descending order? See, it is one. If I go in the reverse, I wanted to read the latest inserted record I wanted. I'll go with the -1. It will tell you the latest is this is the latest record. So how it is actually filtered out based on this ID. ID has an index again. Index knows the data is already sorted in the background. With this ID field index, it has every record reference in the sorted order. That is why you are reading in the sorted order, in the ascending order, descending order, irrespective of the amount of data. It can read. If you don't have the index on this one, it will throw the error when the data exceeding 32 MB. That should not happen. So that is the reason it is adding a default ID on that field. Basically, when you are reading with this ID, it should not reject your read operation. If it should not reject, you need to have index by default for sorting that data based on the ID field, the default ID field. Anyway, that is exception. No need to worry. We don't read that much, but when you are reading it, it need an index. That is why it is creating on its own. So single field index. This is what is a single field index. We are creating the index on the name and particular only one field. Okay. Let's move to the next, guys. Index on an embedded field document, right? So this is also important thing. That is why I entered student data. DB dot. Let's finish this as well. DB dot student. Find. We have two records. So now, if I'm trying to read example for the sake of discussion, I'm trying to read address street Kukatpalli, right? Or else address street OU colony, whatever it is. So now what happens in this case? Will it use index? We don't have index. It won't use index. If it want to use index, what happens? What happens?
It
It
will
will,
scan the entire connection.
it can all the entire.
Right. It will read all the thing. If I'm trying to read the execution plan for this, just explain. It is clearly tell that collection scan, clearly saying that. So how do I create index on this one? If I wanted to read as based on my read, actually I wanted to filter the lot of data on every day based on the address, basically who are belong to that particular address. So how do I create the index on that one? So db dot student dot create index. Actually, you should not create the index any product. You need to understand the read patterns. First understand the patterns, then introduce the index. Just blindly creating index does not make any sense and it won't help you out. Anyway, so I'm creating the index address dot what was it? Street, right? Street. What should I give here? Either one or -1. It's an index basically. It is created index. Now the same thing if I'm trying to do this one now, it is index scan. And if you really wanted to see that is it really using the index? Yes, it uses one document only, it will examine one document only, it will give you because you have the index. Execution stats. Come on. Execution. Right. So total how many documents it is examined first that we need to look at. Right. See, total examined one, given one. Why? Because it has the index what you are reading it. What you are reading it, it has a index basically. That's how the single field index will help you to read the data when you are including that in the predicate or condition. This is a condition. It's not a projection. We are reading everything in the projection, but only this is the data you have to filter it out, right? So on that condition, we created the index. Always create the indexes on the conditions, basically. Right, that is called what is embedded field document index anyway. MongoDB provides complete support for indexes on any field in a collection document. You can create the indexes on fields within the embedded document just as you create on the top level fields in the document. So it is simple, guys. So we just seen just now details.isdb. So details is a parent field, isdb is a child field, and these two fields we are trying to do it. One more thing, let me do this. Instead of the street, I'll try to find something else. City. Will it use index? Question. City. Will it use index or not? Tell me.
No, right? I mean, like, we didn't create any index on
Right.
address.
It won't use as simple as it is. Wherever index is there, if you are referring that particular, like the index pattern, then it will pull the data. Is address dot street only when whenever you are using that in the filter, it will definitely use index. If you are skipping that, it will not use index because other fields does not have index. As simple as it is. So to create index on you, this parent field, the child field, and you are introducing the index, and you are reading this pattern. That is why you are creating that index. That is about single field index case. Compound indexes. Let's come to this one. This is very important thing. This is where we spend a lot of time today. Compound indexes are very important in terms of like efficient index management. One index can serve a lot of purposes. If you know how you can create a compound index, even it applies in the RDBMS and any product basically. So now, as I was saying, db dot, okay, lab, come on, find. This is the data we have, and we have the index on S number, right? When I was reading the Santosh, what it is doing actually, db dot, let's do it, and then come to the conclusion. Find, I'm going with the name. When I go with the name, anyway, it will not use the index. I'm going with the number, S number, one, S name, sorry, S name, S number two, S number two, uh, S name Santosh, right? Santosh. If I read this, it is actually examining, explain. I'll tell you what I wanted, what I'm trying to tell. Execution stats. If you see what's happening here is it is examine total 4 documents and return 2. But is this efficient actually? If you have millions of record and people names are matching, IDs are different but names are matching. Why? Because the condition is giving 2 fields to take the advantage of the index. That is why you are using this basically. The two, this number is can be anything, right? Only. So how you can achieve this kind of situation when you have matching data, a lot of records are matching, and again filter is on the name on the matched records. If that is the case, you have to go with the compound indexing model. Compound indexing model means we will create the index on 2 fields at a time. Let's do that. S number. See, compound indexes will help you whenever you have the combination of data is giving some common data. Again, you wanted to filter it out like a non-clustered. Exactly non-clustered. So I'm creating an index like s number, s name, and s name, s number, s name. Both I'm creating index on both the fields. It got created. Now if I do the same thing, I have created an s number and s name, both the indexes. Both the indexes uniquely read the data now. If I go and do the explain execution stats, it went with the collection scan anyway. Sorry, index scan, both have the index. If you see total number of documents examined 2 and given as also 2. Why? Because both the conditions whatever you passed are having the indexes. This is what you need to understand. To tune the query, first thing, what condition people are using and what fields they are using it. The combination you have to create the index combination together, because two fields you are using as a condition, the condition have the index properly. So if these two combination, it has the unique entries in the index addresses. So where you're reading Santosh, where you have the number 2, it is directly going into the number 2 field. In the number 2 field, again, the exact name of it, it is keeping it. So how does it sorts in the background? Let me explain this quickly. TP dot. Number is fine. How does it actually sorts with the name? Name is a letter, right? It starts with the alphabetical order, and this one it is number, and this one is alphabetical order. It is going with the first index and the common. Okay, it is find 4 records. In the next index also is a condition, and it has a combination of it. So where this S is starting, S is starting with Santosh. If example, in case of Santosh, you have some other name with starting with yes, but still it look for the next letter, Santosh SA. So it is going with the alphabetical order A to Z and Z to A in the reverse order. And at the same time, if you have the matching records, it will go and search for the next record, next entry as well. It will give you the exact records, guys, as simple as it is. It is going to examine exact number of records, what it is giving the output. Whenever you are keeping in the condition, the values what you are trying to read. You guys are catching what I'm trying to say? See, the index patterns based on the conditions you supply. The conditions are giving you more redundant data. Introduce the indexes of the condition given field, so that it will keep the minimal output because you have the proper indexing model. Following?
Yes, Ravi, yes. Yeah.
So let me tell you one thing, guys. Let's come back to the slide. Anyway, I'll conclude this. No, I did not finish it yet. MongoDB supports compound indexes where single index structure holds the references to multiple fields within a collection. Single index, it is giving the multiple fields references. Compound indexes can support queries that match the multiple fields conditions. See, item and stock, two fields you are creating the index. If we are giving this condition like db.find, you are giving the condition these two fields, it will use the best indexing model basically. The order of the fields in the compound index is very important. So now I'll tell you this way. If example, I have the index and S number and S name together. If I'm trying to use the only S name instead of S number, will it use the index? What do you think? But S name has index along with S number, not independently. S name. This is what that was saying actually. Let anyway I'll tell you. S name, why one is mentioned in the script. One means ascending or descending. This is what I was saying. One means in the 1, 2, 3, 4 order. It is -1 means like higher to lower. It is keeping the references with the data. Though data is got jumbled in the physical. Okay, got it. Good enough. It just references in the order. That's it. One means without 1 or -1, you cannot create the index. It is mandatory. You must do that. So I'm trying to read a Santosh record now. Will it use the index or it won't use the index? It's a question. I'm trying to read, but it
It
has the
reads,
index.
yes.
It will
It
use
uses
index.
index. Yes.
That's where we go wrong. Even in the RDBMS also, it is absolutely the same pattern. You should use the pattern, then only index will be used. Else it won't. I'll explain, don't worry. Execution stats. It won't use the index. Why? I'll tell you anyway where it went wrong. Exe.
Execution starts in double quotes.
Oh yeah. Sorry guys, and this also not required. It happens sometimes. Right, if you see, this is a collection scan. It is not index scan. It is went to the collection scan. Why? order, the index order is important. Let me explain this. I'll tell you the order anyway. Indexing order. I'll send this document. So just try to follow. The combinations are very important. You need to understand the combination, then only you understand this. I'm creating the index like this: S number 1, S name 1, 1, S address also you have it 1. I'm creating in the indexes on 3 fields. So if I go and read, let's do it. Why to say that exactly? So S number Santosh and address US. So address is US. Okay, I'll change this address to something quickly so that you understand it. One example anyway. db dot lab dot update. I'll tell you what I'm trying to do. Just wait. This number 2. This number 2. Okay. I'm not. It will update both. I need to give something unique again. Just a minute. This number for both of this two, and it'll update both. I don't want. So what is unique here? Come on, everything is same. Not good. Everything is same. Then we cannot update one record. At least one something on one thing. It has to be different. Okay. Any other record we have? RAM, address are all same. Anyway, I'll enter one more record then. I better enter. Just a minute. To make you understand the next topic, I wanted to make one scenario. I'll tell you. I'll explain with this data so that you understand well. That's number 2. This is enough. Right. So if you see this one, if I'm trying to read, try to understand this. db dot lab dot find. I'm trying to read S number 2 and address S number 2, S name, and on third record we are going with the another record indexing model. Santosh condition address is US. So now tell me, we have the index on this one and this one, and an address is US. How many records it will read? There are three records. Oh, come on. Okay. This is the last example on the component index. I'll move to the next one, but this is very important to understand. db dot lab dot find. If you see, to Santosh is there are 3 records, right? 3 records. So now I'm giving the condition like this: db dot lab dot. You have to tell me this. If it will use the index S number 1, S number 2 actually, in fact. S name is Santosh, and address. Address, address, giving US. So how many records it will read? I mean, in the background, it will give you only records as an output, only 2 records. But in the background, how many?
4.
Why 4?
because address field doesn't have an index, and all four of them with the serial number 2 has US.
Yeah, but we have index on the S name also. So it look for three Santosh. This field also will be matched. The next layer. Next layer indexing is also there. Here, here, here. It will read only three, but it give you two. I'll tell you anyway. Execution starts. It's a little dry subject, but try to understand. If you see, it is an index scan, good enough. It's good. But if you see the total examined document is 3, but is written 2, it is not good. It is not matching the value. It is reading the unnecessary documents and giving you the 2 records only. When there is a small difference, which is good, but if it is reading 1 million records, giving 2 records an output, though you have an index, it does not make much sense. I mean, it is reading unnecessary data, it is creating the performance impact. Then to get that, what should I do then? I have to create one more index basically. So one more index like this. I'll conclude this. This is a very lengthy topic, especially on the compound index, to make you understand. Create index. Anyway, I'll conclude this tomorrow. No need to worry. I'm creating one more index combination. You have to create like this: S name 1, address 1. Okay. Now you have the indexing on 3 fields. Now if I go and read the same execution plan, it will read exactly how many records you wanted to read. 2 documents it is examined, 2 documents it is given. This is what you have to look at especially. Total how many it is read in the background, how many records it is giving you in the front end. Based on that, we have to introduce the indexes. So now let me ask one question. This is the indexing, you have it. So I'm trying to read data in this S number, only S number with that indexing model. We'll use the index. Let me do this. db.getIndex. Just a minute. What I'm going to, I'll ask some questions. Then only you understand this. These many indexes are there. I'm going to drop these indexes. Let me drop and ask the questions. db.drop index drop index. We have this right. I'm going to drop this index name. I'll tell you why I'm dropping it. It is intention. I'm dropping this index as well. Right. Now, if you see, we have only 2 indexes. One is a default. Default anyway, it's not for us. It is for the system. And this is in 1. So in this case, if I'm reading only, just try to understand. This is, if you understand this, you understood the indexing model and the compound index. If I'm reading only on Santosh or on some ID, db dot find a db dot lab. Understand this, very important. I'll conclude this with the combinations anyway. S number, example 4. How many documents it will read? Look at it and tell me. In the background, how many documents it will
Three,
read?
3 records.
9.
3, because 4 are matching, right? 4 are matching. 3 records will read, and you can see that. Explain. If you wanted to really verify how many it is reading in the background, you can only use this option. Execution stats. It read 3 documents, it is given 3 documents. Now let me ask something else. db.lab. You have this data. Now, two we have. Anyway, if I go with the 2, db.lab. How many documents will read?
Number
5.
2.
5.
Oh, 5. Okay. 5 documents. So now I'll give the next filter. You have to answer this question. If you understood, then I'll go to the. If I'm giving this, how many document it will read now in the background?
Address US and
4.
Bangalore. 4.
Only 4?
Address US.
Let's read this.
5.
So, all right. Let me explain and come to this, and I'll explain it, what it does in the background.
Index 5.
If you see, it read in total keys examined, total documents examined 4, and given as 4. Why? Why it is given this basically 4 only? It read 4 only, given 4 only, but there are 5. Why it is so? That is a question. That is what you need to understand here.
Because
So
it
if
is only checking address field as well.
right, we have the indexing on the address field as well. So let me tell you this thing. If you use the only one field, it use the index. It use the index scan. If you use a S number 1, let me write the combinations anyway. S number, S name, asset, S name. Okay. You have to tell me whether it will use index or not. S name, address. This one combination. Oh, sorry, this must be S name. I'll show you. We have time, 10 minutes. That's enough. I'll show a few examples. You understand it. S name, address. Okay, only address I'm reading. Next, what are the common S number, address. Okay, right. And what other combinations can come? Address, S name. What other combination? You can see it here. S name. Any other combination? S number, S name, S address, S number, S address. Okay, this way. Address, S name, S number. Right. So now I'll ask on each one, each combination. These many combinations can come. These many combinations people can read later. So which pattern we have to suggest when we have this kind of index? They should not read a random pattern to get use of the index. So now tell me whether this will use index or not. Index will use or not. It is. We have only one index. We have only one index called compound index right now. db.lab.get indexes. We have only one index, which is a compound index. If I'm using only S number, this part, will it use the index? Yes, it will use the index. As long as you follow the order, as long as you include the first field, it will use the index, the conditions. Just try to follow conditions now. So first case, it use the indexes. Yes, it will use the index, basically. Why? Because it is following the order. db dot lab dot, just try to follow. Find. I'm doing this. So db dot lab dot find S number, anything, it doesn't matter. It is using the index or not, that is what we are verifying. First, you need to understand that. So S number maybe 4 something. It is going to use index or not? Explain. Just explain is enough for us. It is using the index. Absolutely, it is saying that. So next combination. So next combination, I'll go with the S name. S name. Whether it is there or not doesn't matter. Index is using or not matters. Maybe I'm giving Ravi. Still, it using the index scan. So now just I'll go with the. So this combination also will use the index. Which this combination. only one index, but it is working with that combination also. That is what I wanted to prove it here. So for everything, I'll read once and then show you once. Better maybe understand better. All right, this is the data. I'm trying to read this way. Fourth record, we have multiple, right? So Kumar, how many records it will read, if at all, if it reads? Can anyone tell? How many records it will read now? Because we have the index on S number, S name, S address, 3 fields we have. If I go with this, how many records it will read in the background? 1 or 3
One.
records?
One.
One only. Very good answer. If you understand this, you understood the indexing model. Seriously, on the compound. Execution stats. Even RDBM is also the same. Even SQL Server is the same. If you see, something wrong I did. Just a minute. It's number 4.
S name, right? S name is spelling.
Right. So now let's see. See, examined one, given one. One index is giving you more patterns. That is what you have to pick up. Index. Don't create the individual unnecessary index. Create one index that should, that will fulfill the more criterias. That's what you have to think, as a best DB and efficient DB. This is the data. So now it is using the index. Okay. Now it is using the index and is reading exact data what it has to. Now I'm going with this combination, 3 combination in the condition. Still, okay, let's go with Santosh in this case. Why? Because it read exact records. That's what I wanted to prove. It is using the index, Santosh, address. So now tell me how many records it will read. Look at the data and tell. And we have the index in all these 3 fields. Wherever Santosh is there, first criteria is to total 1, 2, 3, 4, 5 records. But and the second one also we have index. It is also filtering here 1, 2, 3. And third record also we have index. So Santosh is here, address, this is gone. This is gone out of the queue. And these two are matching. So how many records will read now?
2.
2.
2 only. 2 only. It will give you, it will read 2, give you 2. That's what indexing benefit is. There it is. Right, see, it is read 2 and gave you the 2. Now come back to this. So this is also using the absolute index. If you are going with this combination, if I go this combination, will use the index? That's another question. Now let's do it. This is the data. And this is the same condition I'm going to give. What happens now? Oh, come on. What do you think?
It will use
That's
Yes.
fair. That's
because
fair. That's
we have an index on S name.
But S name has a combination with S number. That the first value of the index must be called. That is where people do another big mistake in the indexing model, especially if you are creating index like this, the starting value either you follow the order, or else include this first starting of the index. It is even in the RDBMS also the same. If this is not included, it will not use the index. This only if you are trying to read only these two, you miss the order. If you miss the order, you need the first value of the index. Then only to use the index. That's how system work. So now, if you see this one S number, okay, S name, address, S name Santosh we have where? To 1, 2, 3. But US how many we have? 2. It will examine 3 documents and give you 2. Basically, no, it will examine all 7 documents basically. Not because it is not even detecting any index because there is no indexing on these two one. If you're trying to read this pattern, it will read all 9 documents, give you 2. Let's see, because that does not detect the index at all. Where this one? See, what I have given, just a minute.
Examine 10 documents.
Right. Where it is? Right, here it is. Total examined 10 documents, but given 2. So this is not at all going to use the index. No, this combination, no. And this one, based on the previous one, will it use index? What do you think?
No.
No.
If you understand this, you get very closer of the indexing values. It works in the SQL Server also the same way. Any product you take it, the indexing model is like this only. That is what you have to follow the pattern, not the index. Just go, don't create the index blindly. So if I go with address, now I'm going with the US. So how many documents it will give you? How many documents it will examine?
Examine all and return 5.
Why?
Right. Wherever US is there, 1, 2, 3, 4, 5. That's correct. Very good answer. If you see, examine all, 10 documents is examined and 5 documents returned. Exactly. This combination, no, we proved it. No, this is also no. And this one,
No.
it's question.
No.
This is another part thing we need to keep in mind. The starting value of the index, if it is included, the order does not matter. Any order you read it, it will come. The starting, see, it's a compound index. The starting value. So it will go with the filter of that one anyway. I'll show you. You understand it. So now the condition, I'll go with the US is address. Okay, S number is 2. So now what it does, this is a question. Will it use the index scan or collection scan? First, that thing I wanted to ask. Previous case is collection scan, absolutely collection scan. And here also, no means collection scan. Yes means index. That is what I wanted to prove here. So will this use the index? Yes, it will use the index. Come on, where I am. So if you see, right, using the US, now how many documents it will examine based on this? If it uses the index, how many documents will examine? How many documents will return?
5 and return 2.
5
That exactly
and
correct. See, 2
3,
is
right?
actually 2 will return. Why? Because Santosh is address is US. Oh yeah. See, that is one more thing. So you need to look at this 4 and 5. Out of this, how many USs are there? So these 4 will come, right? So these are 4. 4 are matching, basically. 4 are matching. So 4 will come, it will examine 5. It is using the index, which means it is not just going with everything. It is using the index. If you click on this, just a minute, 1 minute, I'm back. Sorry, I'm back. So now, if you see that the indexing model, it uses the index scan. It is scanned total scanned where it is. Come on, just a minute. Total examined are 4 and given also 4. Okay, it is use a complete indexing model. If you see, total keys examined at 6, but documents are examined 4. See, you need to understand this is called key lookup again. It went with a key lookup. Why? Because on the first index, first number, you have 6 documents are matching. And the second one, 4 documents are matching, it is giving the 4. This went with the key lookup. Key lookup is also an expensive operation. How do you avoid the key lookup? You have to follow the exact pattern, all indexing pattern. Key lookups are also not good. We have a key lookup concept in RDBMS. We have the key lookups in the Mongo also. Keys are examined. Why 6 are examined? Because there are 6 twos. But how many US addresses are there? That is what next condition. 4 are there. 4 it is giving basically. Are you guys following this? It is using the index very good. It is not reading all the document. That is something good. But it is actually on the first field. Try to follow this. Very important. See if I'm doing on the first field, how many are matching total? How many? 1, 2, 3, 4, 5. How many are there? Why it is 6, 4 and 5? It should be 5 key lookup. And then US on this S number 2, this is not US, and these 4 are US.
No, because S number 1 has a US, so it is scanning for
Oh
a
yeah,
US. It's US as well as S number 2.
that's correct. Very good. So this is what, this is not efficient. This is not efficient condition. This is not efficient condition because it went with the key lookup. It is keys means total document. It is actually examined 6, but given at the end, it went with the keys actually because it is matched with the US also. This is matched, and this is not 2, but this is matched here with the US. But condition is both should be matched. Then only we need an output ultimately. But it examined the 6 documents total in the background, not 4. Examined 4, it is showing as 4, but it went with the 6 documents given as 4 as. So you need to understand that way. It is something comes with a lot of experience, but anyway I'm giving you the ready-made knowledge. So it is examined 6 document, not 4. It is showing examined at the end 4, but key lookups, it went with the key lookups. Why? Because with address 1 is extra matching, and with the keys 5 are matching. Total 6 it is matching. So it is examined out of all, and the combination we need in the output, the combination are 4 you wanted in the output. The key lookup, this is also important thing you need to look at, have a look at, not just this is matching, good enough. No, you have to go with this one. Now I'll ask one more question. I'll ask key lookup also, if you understand. Give me 5 minutes, I'm done. 5 minutes, I'll finish these 2 combination, I'll close it off. So now first I'll read the data. I'll go with the all right, let's go with this way. I'll take out the address. Now tell me whether it will use index or not. First question.
Yes.
Yes, we already gone through that combination S number S name. But will how many documents it will return? Next thing. Santosh, 3 documents. Out of 3 documents it is matching, right? 1, 2, 3. But actual 2, how many are there? It is a sequence
5.
anyway. It will anyway it is sequence. As we are following the sequence, it does not go with the key lookups. This is a good condition basically. If you see it, 3 records shall examine. Key lookups also it should match where it is examined. Come on. Right. If you see, keys examined 3 and total examined 3 and giving you 3, all 3. Why? Because we are following the index pattern in the order. As long as it is in the order, it does not go for the key lookup. It must be order. In this case, if you see this case, we are not following the order. The index is created S name, S number, S name, S address. If you follow this order, it does not scan the extra keys at all. When you don't follow the order, it is using the index anyway. It is giving you the good performance, but keys are actually examined because of you're skipping the order. If I go with the address and S name, will it use the index quickly? This is using the index we have seen anyway. but key lookups, but with key lookups. Okay. And this one?
No, it
No.
won't.
Right. Very good. If that you understood. Now this one?
No,
No.
Yes or no?
No.
no,
Yes, actually. Why no? You have included this.
no,
First
but
field,
it's not in
But
the
it has to
sequence,
come in
right?
different, right?
it's not.
It's
But it
not
has
in
to
the
come in
sequence.
different
Order
pattern.
is missed. When the order is missed, the first field is included, index will use. That is also another condition I was saying. If you are breaking the order, S number, S name, etc. See, in this case, where the already one case we discussed, this case is using the index, but with key lookups. It is using the index, but with the key lookups. Now let me make this. Whenever you break the order, first index, the first pattern of the index must be included. It will use the index. It will give you the good performance anyway, anywhere it is used. But the key lookups, it will go into the key lookups, and anyway, key lookup is somewhat better than the scanning everything. So, but when you break the order, it will go with the key lookups. That is what you need to understand. This is the last topic anyway, last combination. We are done. Bear with me. So now I'll read the address in the reverse order. Let's read it. Actually, if you include everything, key lookup also won't come. Let's see. That's what I'm thinking. Address is yours. I'm keeping it. Okay. S number 2. No, S name. I'll keep this name. Any direction anyway. S number in the middle also is fine. Anywhere, it just has to be included. S name. So now, how many documents will come out? It's a question. No document will come because S number should be there 1. 1 there is no Santosh, so I'll keep it 2. With that condition, no document will come out. Now, tell me what happens in this case. Will it use the index or not? That's question. First question. Let's see the key lookups, all that next thing. Will it use the index or not? Say something. I'm saying this pattern, guys.
It will use but key lookups.
Right. That is what I will. S number and S name. This is a combination. Yes, it will use the index. Whenever the first field of the index is included, there it will use index for sure. Wherever see, wherever is no is there, there is no first field. The rest of the things are all everywhere index is using. In these two combinations also index will be used. Okay, let's check this out. But can anyone tell how many records will come out based on this condition? We'll see how many it will do that, but how many will come out?
3.
So Santosh is 3 is occurrence, but yours occurrence is twice. Only 2 will come out. But let's see this what it does, the execution plan. That is important for us. It went with a good index scan, that is expected. That is what I was saying. Though the order is missed, you had to include the first index field. That is important. If you see total keys examined to this is another good point you need to understand. Though order is broken, all fields are included. Yes, included. Then it will use the complete index. If you break the order, see here we broke the order, and we broke the order, and one field is missing here. If the field is missing, then it will go with the key lookups. Here I break the order, but I given all the fields to it. See guys, try to follow. This is a huge topic. Yes, I do understand. But if you are giving all the fields, it knows actually you have the index and all those things. Even if I go in the reverse order like this, it still examine 2 documents only, because all fields are supplying. It knows internally 2 documents are examined, 2 documents are written. Key lookups are also 2. Following? Confused, right? Say something, please, because we are out
No,
of
no,
time.
makes sense. Yeah, makes sense.
Makes sense, right? As long as you include the complete fields, any order, it will pick up the index because it knows you are the keys. System knows the keys anyway. Like address also have index and sname also have index, and this is also index. Now, if I break something, if I go in the reverse order, address and s number we already discussed, right? Yes, address and s number. Address and s number. Did we discuss an address? Okay, S number and address. It will also in the reverse order also it will go with the key lookup anyway because the order is broken. Now what it does? Now if you do this, let's do this way. It will use index anyway. It will use index. That's something good. Index scan. But see again, key lookups. It went with the key lookups. Extra 6 records and 4 documents. It is given. So key lookups are more. This is also a little bit. See, index is good first. On top of that, you wanted to get the actual benefit of the index, complete index, then you also try to avoid the key lookups. Key lookups will also an extra load. It read 6 document instead of 4. So 6 is also a waste of resources, right? So that way you had to understand the pattern, what pattern people are reading it. See, one index, we created only one index on this one. One index is serving lot of patterns. So which means that if you create an index and s number, and you have to include the s number all the time, then only you get the index. If you go with the s number and s name, it will go with a lot of key lookups. Why? Because other field does not have the indexes basically. So that is what you need to understand. Which pattern will give the best efficient execution plan with a lot of pattern. If I'm creating the index on 3 fields, it is satisfying a lot of conditions, lot of combinations. If you see, these are the combinations where you are getting yes, yes, yes. Only 3 combinations are not getting the index used. Okay, index used. So in all these fields, you are getting the index benefit, and that is what you need to look at. That is how you have to introduce the index. You have to take the call very cautiously when you are creating the index. Even in the SQL Server also, this concept will apply absolutely. Anyway, I'm going to cover. I'm building the SQL Server performance tuning. If anyone interested, we'll see in the future. But indexing is very interesting topic. It has a lot of directions to tune the system, not one. Don't go blindly. Blindly, if you are creating, it won't improve the performance. You need to understand the workload and introduce the indexes. That is where you get the actual benefit. Anyway, compound index is over, and I'll finish the rest of the things tomorrow. Any questions? I'll send this document, right? Any questions? We did compound index, single index, and embedded document index. 3 things we have done, but two types are finished today. Any questions?
Yeah, this is out of this.